Hello, my name is Francesco Coletti. I'm the CEO of Hexxcell Limited. For those that don't know Hexxcell, we have developed the first hybrid digital twin for predictive maintenance of heat transfer systems, and in particular, heat exchangers and heat exchanger networks. And that's really what I'll be talking about today. How can we use predictive maintenance, and how can predictive maintenance help meeting ambitious net zero targets that oil companies and government has set for 2050. So if you look at the CO2 reduction targets, many companies have pledged net zero by 2050, but to achieve the net zero target, we need to aggressively cut the short-term CO2 emissions. Whether this is scope 1, 2, or 3, there is a significant amount of CO2 that need to be cut by 2030. And 2030 is really around the corner. So reducing by 20, 25, 40% CO2 emissions means that we need to start today. And what I'll be looking at in this presentation is really what can we do today using digital, in particular using predictive maintenance, in order to help achieving these goals in the short term. If you're looking at various technologies that can be used, we can use CCS, we can use electrification. There is a lot of talk about electrification, but all of these technologies are really 5 years away, if you're lucky, if not more. So 5, 8, 10 years away to be at scale and really make a dent in the amount of CO2 that we are emitting. So the question is, how can we use digital to support these goals starting from today? So if you look at where global refining emissions are coming from, the vast majority are coming from some sorts of heating, okay? And if you're looking at where they come from inside the refinery, so if you look at the breakdown on the right-hand side for the different unit in the refinery, the vast majority of the CO2 emissions, or the CO2 equivalent, the greenhouse gas emissions, come from the crude distillation unit, the CDU. And in fact, the vast majority of those emissions are due to the fact that the furnace at the CDU is emitting significant amount of greenhouse gases. So if you look at the CDU in detail, we have the furnace, which brings the crude from ambient temperature all the way to the distillation column temperature, which is about 350 degrees. And we have a train called the preheat train that helps the furnace to do its job, to do it cheaply because it reduces the energy requirements, but also to do it more environmentally friendly because the CO2 emissions there that is able to help the furnace not emitting. And so what we typically do with our customers, we look at a breakdown of the individual heat exchangers and see how these contribute in terms of the duty to the overall furnace support to the furnace, right? So how much duty is actually recovered from the hot streams at the distillation column in each heat exchanger, and how much duty is actually lost at the individual heat exchangers, and how much the total amounts for. And in many cases, what we see with real data, this is obviously a bit of a simplified Sankey diagram. Real life, you have many more heat exchangers. But what you can see is that the vast majority the good portion of the energy, in fact, more energy is lost than the energy that it is recovered. So the question is, where does this energy go? Vast majority of the losses are actually due to fouling. When we heat up the crudes, the crude deposits unwanted material on the thermal surfaces of the heat exchangers, which reduces the thermal effectiveness, increases the pressure drops, and leads to loss in production, increased fuel consumption, and so on and so forth. I will put to you that it also creates a lot of disruption in terms of operations. We need to open up the heat exchangers with some related safety concerns there, with cranes, etc. And then needs to be the heat exchangers need to be clean, etc., etc. Not a pleasant job to do. The impact of fouling and these losses generated by fouling in the preheat train have been evaluated in very large amount of money in terms of the production losses, about $10 million per on 100K barrel a day refinery, a significant amount of extra fuel needed at the furnace, and a significant amount of CO2 emissions. This 2.5% of man-made emission due to fouling in preheat training crude distillation unit is what you find in the literature, is a number that you find in the literature. It's perhaps a bit too high these days. We see a little bit less, but nonetheless, it's a very large number. Now, what do we do about fouling? What do we do to mitigate fouling? There are a variety of technologies that can be used, and they are used in the refinery to mitigate fouling. We have some options which include redesigning the heat exchanger, include, for example, using technologies such as coatings, loafing tubes, tube inserts. But all of these technologies, they need capital, but also we need to stop the plant to be able to implement them. And their ROI, as a result of the fact that there may be some expensive options, can be lower than what we think, especially because, for example, if we implement coatings, coating might extend the time that regular cleaning is required, but nonetheless, regular cleaning will be required. So most of these technologies, while they may mitigate fouling, they may reduce the amount of fouling, they will still lead to some sorts of cleaning at some point. So what I'm putting to you today is that the role of prescriptive maintenance, which is on the top right of the quadrant, where is very effective, can be effective with very high ROI because the cost is quite low of the technology itself, and it helps minimizing the unnecessary actions and perform only the optimal ones. It's one of the best options that we have. Possibly designing slates that minimize fouling is what might drive even better ROIs, and that's something that we also do at Hexxcell. But what I would like to focus on today, it's really the prescriptive maintenance piece. So I don't think I need to talk too much about prescriptive maintenance to this audience, but we see it as a journey, really a journey moving from a reactive approach where we only clean, when we talk about cleaning of heat exchangers, we only clean when there is an issue. So we react to a problem. For example, we hit the furnace limit, then we clean. We lost production, then we clean. And all the way to the prescriptive piece, increasing in value in terms of the different steps that we are taking. The next step from reactive approach is the preventative approach, where we use a time-based approach to clean the heat exchanger. So we decide that on a regular basis, we clean certain heat exchangers so that we minimize the energy load at the furnace. But again, actions here are not taken in an optimal way, and they can be not necessarily the right action at the right time. If you want to increase on the scale of value that we provide to the refinery, the predictive approach is the one that we want to aim at. We want to be able to use model-based predictions to plan in advance maintenance actions before we have a problem, before a problem manifests itself, before we hit that furnace limit, before we hit that hydraulic limit. And the further piece that we do at Hexxcell is the prescriptive one, where we look at not just when is optimal to clean which heat exchanger, but also which action should I be taking? Should I be taking a mechanical cleaning? Should I be doing a chemical cleaning? Should I be using ultrasounds? What are the benefits of these different technologies based on the state of the equipment and based on the economics of the entire plant? So the benefits of this, if we can implement this type of approach, are very large, and they really go into map into those limitations and those losses that we have seen before. We can increase production, we can reduce fuel, and crucially for this presentation, we can reduce significantly CO2 emissions. However, to tap into these benefits, we need to be able to predict fouling and describe cleaning in a very detailed and accurate way. The problem is that fouling predictions are not easy. They are system specific. They depend on the type of fluid, depend on the process conditions, depend on the surface conditions. There are a lot of phenomena happening. They are complex, they're interacting. So in our experience, the AI plug-and-play approach where you implement and forget doesn't really work. So what do we propose to do if that's the case? Well, we developed what we call hybrid digital twins, where we integrate artificial intelligence with deterministic models. So we go as deterministic as possible, but we use a layer of artificial intelligence and mathematical optimization to help the deterministic models to do their job. And we do this by implementing in the deterministic models deep domain knowledge, and also in the approach of how we use artificial intelligence, we use our domain knowledge. So what we do, we collect the data from the plant, we process it in our hybrid digital twin that can be on premises or on the cloud, and then we provide to operators actionable information and clear indications on what is the optimal action to be taken at what time, and what are the benefits that will derive from that action. So let me show you this with a case study for a European refinery. And what I would like to show is, put in perspective the differences, particularly with respect to CO2 emissions, moving from a preventative approach to a predictive to a prescriptive one. So what we did here was to build a hybrid digital twin for a European refinery, 120,000 barrels a day refinery, which was already extremely well managed. And once we built the digital twin, we assessed what the refineries have done in the past 4 years, and in terms of the cleanings, what cleanings do they implement, and how much money they were able to save with respect to the no cleaning scenario. So what if they didn't do anything? What if they didn't perform any cleaning? What would have happened? And what actually happened because they implemented those cleaning? And then we run some what if scenarios. What if they used a predictive approach? And what if they used a prescriptive approach? And what is the difference? Can we quantify the difference between these three different approaches? So what the table shows here is what the refinery have done over the 4 years of operations that we considered, and implemented 15 mechanical cleanings and 2 chemical cleanings. And they were able to save themselves over 2 million over the period with respect of don't doing anything. Now, as you see, production losses are set to 0. We have not considered those. Our tool allows us to identify what are the production losses depending on what actions we are taking. But in this case, to be able to compare apple with apples, we did not include any production losses in the analysis. We wanted to focus only on energy. So in terms of energy only, the refinery were able to save over $2 million in 4 years of operation, and about 4% of CO2 emissions with respect to the case of not doing anything. Now, if they included a predictive approach, if they used the predictive approach, which means that they selected only mechanical cleanings, but at the right time, performing the right action at the right time, they would have been able to save 4.3 million more than they already did, and reduce by 3 times the CO2 emissions that they were able to save. Now, what if rather than choosing only the optimal cleaning actions, the optimal cleaning time, we're also selecting the optimal cleaning action? What would have happened? What would have, how this number would have changed? And that's the prescriptive piece. So the optimizer would have asked to perform more cleanings at a higher cost in terms of maintenance, but at a significant reduction in both fuel consumption and CO2 emission savings. So to conclude, I believe that digital has a key role to play, particularly in the short term, to help achieving the ambitious net zero targets that we have set. We have seen how a large portion of CO2 emissions in the refinery, almost 60%, come from some sort of heating process, and a significant portion of it is lost in the crude distillation units. Of the energy is lost in crude distillation unit, and this is related to a large amount of the CO2 emissions in the refinery. I also showed you how shifting from a reactive/preventative approach to a predictive prescriptive approach can have a significant impact in reducing the energy consumption and the CO2 emissions of the refinery. In our view, the hybrid digital twins is what can enable to tap into these benefits with a very large ROIs and very short paybacks. That's what we see already today. We don't have to wait another 8 years before we start cutting the emissions. And with that, I would like to thank you and take any questions.
Thank you, Francesco. I'll tell you one thing, that was a fantastic presentation. And it shows you the significance of again, using these digital twins for emission monitoring. But those figures were unbelievable. You know, what sort of, you know, emissions you let out and how much you say. I mean, this is unbelievable. And you'd think every company that would see that would think, right, we are going to do this now. Because it's incredible, absolutely incredible. So thank you very much. It was brilliantly explained, Francesco. I'd like to just ask you a couple of questions just on the presentation.
Sure.
In particular, because obviously you talked a lot about predictive maintenance, hybrid digital twins. Could you expand a bit on the use and importance of the hybrid models? Because we talked about that earlier in the opening panel, but also with regards to predictive maintenance. And in particular to the heat exchanger example you've shown as well. So what's sort of your opinion on that?
Yeah, I mean, we talk about AI and predictive maintenance with AI, etc. When it comes to heat exchangers specifically, which was the topic of my presentation, we see that it's very difficult to go ahead with AI alone. Why?
Mm-hmm.
Well, multiple reasons, which were explored as well in the panel. But one thing is, for example, thermocouples are missing, right? So, and the job of the plant is to keep the plant, the job of the operators is to keep the plant at a specific point. And so the richness of the information is really missing. The deterministic models are able to help the missing measurements, determine the missing measurements, are able to give a more precise calculation of what is actually happening inside the heat exchanger, but then the artificial intelligence will help the models perform their job and correct when is needed, and add capabilities that the deterministic models would not have. And I have to say, this is we have developed I think we can claim this. We've been developing the first hybrid digital twin for this specific application. When a lot of people were looking at artificial intelligence only, we're looking at deterministic models only. So we've seen that the combination of the two is actually applied in real life now, and we're happy to see that that's where the industry is going.
I think it's good to claim it, Francesco. I think it's a fantastic concept, and it's really, what's good about it is that you can see the work in progress. Obviously, what you're doing also, you mentioned the refinery that you're working with, and even though, as you mentioned, they were already managed pretty well, you could see, you know, the impact of that within the actual company, which is fantastic to see. I think people want to see results as well. We talk a lot about these wonderful tools, but when you have someone actually saying, look, these are the results of what we're doing, it makes it even more impactful. So one last thing, because obviously you discussed fouling, which I've been reading about a little bit the last couple of days. I did not know it was so bad in terms of money going out and how it impacts a refinery as well. It's pretty awful, actually. So in crude, let's say preheat trains, how big a problem is fouling in other units?
Yeah, so I presented some figures for crude distillation. That's where our main attention is, because the numbers are very large. The whole throughput of the oil goes through the crude distillation unit, so that's where large numbers are. But fouling is really ubiquitous, and this is as old as oil processing or petrochemical processing. You find it in water cooling. You find it in feed effluent reactors. You find it really everywhere. So as I said, our bread and butter is crude distillation unit, and that's where you probably get the biggest impact by using this type of technologies. But there are a lot of other opportunities that people may not be considering, which are really unlock a lot of energy savings and CO2 emissions.
That was crazy. I mean, I couldn't believe the numbers that you were actually putting through on your slideshow. So it's really, really impactful. Thank you very much, Francesco. It was lovely having you present. Hexxcell are the official predictive maintenance partner for the event as well. So please go and see them at the booth. and also contact Francesco directly for any other questions. But we speak later on, and obviously Francesco's also on the opening panel tomorrow. So thanks a lot, Francesco, for your fantastic input.
Thanks, Adam. Thanks, everyone.
Fantastic. Now we move on to our lunch break. It's about half an hour, just under half an hour. We come back at 1 o'clock sharp. We've got a tremendous afternoon planned for today. We're getting quite, well, let's say deep diving into decarbonisation and digitalisation, let's say from 1 o'clock onwards. So join me back at 1 o'clock.